Today we're just slotting in, before moving on to Eurosonic ES200. Just want to slot this in. It's coming away a bit. Harvard 402 MPA. One of my favourite sets, and uses the Cybernet 002F chassis, and it doesn't utilise the bleep. Right, so we've got to have to do something about that. But first of all, this is supposed to be a working set, which I'm sure it is. It's come from Andy at Stockport, so it will have been serviced, but I've just got to take it a stage higher for our customer. And it's things like that. Alternatively, I'd have to supply a set which has got a power socket. So it's nicely lit up, channel 20. I even remembered to print off a thingy, and I even remembered to leave the clipboard in the kitchen. So we'll use the other clipboard. First of July 25, Harvard 402 MPA. Don't any of these have serial numbers on them? There's one on eBay at the moment, that's not got a serial number. Right, I don't know whether this mic's wired for it, but it's a nice mic, standard replacement mic, branded for a business radio customer, and if it's wired right, then we'll use this. I've actually got no receive. It's going into transmit. Just wonder if the speaker's not working. Let's go into our extension speaker, the one mounted on the wall. You know, you couldn't make that up, could you? You couldn't make that up. Now then. Untwazzle the glasses. Right, we'll start with dirty. We won't start with anything dirty. We'll start with seeing whether we've got public address. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. We have. We'll start ticking boxes off. Right, straight away. Dirty extension speaker socket, dirty squelch pot, meter lamp, yes, PA, yes. Right, we'll go into transmit, put picture in picture on so you can see what we're getting up to. I'm on the 3 watt scale, so we should have full scale deflection in transmit. And we've got beyond that, it's doing 4.2 watts. We'll need to drop that. And on channel 40, 4.2, on channel 1, 4.1. Low power, back to channel 20. Low power, go to low power scale, and we've got 240 milliwatts. Non-adjustable on these sets. Go back to full power, and our current consumption is 1.715. Frequency. Test gear's been on a sufficient amount of time. We'll go to camera 2. 2779128, spot on. Deviation, for what it's worth on this test set, wallow. Well, it's all over the place, isn't it? Just listen to it on our walkie-talkie. Testing 1 2, testing 1 2. Yeah, wow. Not even showing you that meter. Wallow. I wonder if we're not in tune. Let's just check the tuning. Wallow. It's reading 5. So when we key up, what does the meter say? Of course it should say 4-ish. Centre the red zone, and it's the high end of the red zone. So I'll put FSD for that. Receive. So 27, let's go back to the meter, you'll see what I'm doing. 27 79125. Two 6 will do me nicely. And now we'll go to the extension speaker, and back with what I was talking about yesterday. We've only got one wire connected, and on these sets it's a floating chassis, so I doubt that we'll get any connection. No. So on this case we've got to apply an earth to that. And I said before, the reason I can only present the inner and not the negative as well is some sets have got an isolated amplifier arrangement. So now there we go. Let's look at the SINAD. We'll go over to the SINAD meter and actually switch it on. These are capable of very good results. .24. .21 with 20. That's not as good as I'd like. It's 1. Squelch. Because I've got dirty volume squelch control, I'm struggling to set that. 100 microvolts. It's exactly where it should be. Now we'll take it to minimum, show you the attenuator, parks at 0.3 of a microvolt. There's the 0.3, there's that, and there's a bit of wire in the way, as you'd expect. Turn the squelch down on the radio, set threshold, signal generator on, straight in at 0.3. Excellent. Check the calibration of the meter. It's supposed to be 100 microvolts for S9. It's a bit high. I've got 10 microvolts. We're in EMF mode, and Andy might be in PD mode. So mine's harder to achieve, you see. So it's 10 microvolts. Right. So, yeah, nice trade working set. Pop the mic off for now. Pleased that microphone fits. Yeah, if you remember, I bought 22 or 23 sets off Andy at Stockport. He's currently got my Calaro RC54 turntable because he knows about those and I don't. I had training when I was an HMV dealer on BSR and Garrard record decks. I had that training at Enfield in Essex on a couple of sessions, and even then they were moaning about the grease and replacing it with oil. There we go. One lid. And detach the squeaker, which at least is 3" in these and not like you get today. Yeah, that's ballast resistors changed, so it's even heftier than I would put in. Right. You know, they were putting 2.5 watt resistors in some of these and 3 watt resistors in some of these. I mean, this is 5 watt. So you're going to have a fighting chance that you're actually going to get 4 watts out of the radio. Can you imagine, you know, got this 2.5 watt dropper resistor and you're expecting to get 4 watts out of the radio? You know, it's not going to do it for very long, is it? You know, like 4 seconds. It's going to heat up and all that. So, yeah, I mean, that looks great. Well, what we're going to do is, we know the set basically works. Let's disconnect it. Tell you what, we'll jump some service sol on that potentiometer. Can always swap it if it's still playing up. See if there's anything we can do with this. There were years when there were no power leads available for these, and years, and eventually we were able to locate the normal square round one, but you can encounter 2 others, and you know it does present a difficulty. I won't do that. I'll tell you what, we'll cut it there. Yeah, that's had the early type, and I think we've got one in stock. Somebody's doing some 3D prints for us, and they've actually copied the old socket. Now, normally what we've done is when you've presented with the big one, which is long obsolete like that, is to put we've got a plate, 3D printed plate. But seeing as Matey's done these sockets, I'll just see if we've got one kicking about. Right, so having dealt with all that, we're now on a normal power lead. We'll just check the VCO. I have no reason to believe it's going to be wrong. We'll select channel 1, and if I can actually find the meter. Perhaps I ought to use my Heathkit meter on this bench with Nixie tubes. So we're looking at the test point, far side of capacitor 9. We can actually get to it on this one. Why is that there? I've never known one so difficult to get to. I can't get to it. I'm going to have to turn the set off and unsolder it and place it in a better position. I'll tell you what I'm going to do, and that's turn it round. It's non-polarised, of course, so I can do that. So we'll put it in the other way round, so that the long leg gives me a bit of leeway. It is supposed to be inserted at an angle so that you can do this test. I've just bent the leg slightly so that I can get it to hold in place. Right, we'll try again. So we're on channel 1. Negative to a coil can that is negative, and hopefully we can get to this capacitor, which we can. And it's 2 volts, which is fine. And just get back on such a way that I can press transmit. Oh, 1.4, not happy about that. I'll borrow the earth from the speaker and apply it to my meter. So we'll do this VCO. 2 volts is fine, but while I'm adjusting it I may as well go a little bit lower. So we'll leave it there. Now we'll see where we are on transmit. 1.4. So it's a little lower than I would like. So we'll go into transmit. Tell you what, stop the PA getting hot. I'll turn it into low power. I'm going to waggle that round just in case it's dirty. Right, so we've got something like 2 volts. Let's go back to receive. We've got something like 2 volts. Recheck. Yeah. Go to channel 40, somewhere around 4 volts. That's fine. It's the idea it's logic high. Good. I said before, if you don't do the VCO, you can end up with channels dropping off in temperature extremes. Like nothing works above channel 37. Things like that. Right, so we'll put the extension speaker back in. Never know which socket it is. Whichever one I plug it into, it'll be the wrong one. Except this time I got it right. So back to channel 20, centre of the band. Going to transmit. The initial ones I may as well do on low power, so we're not heating the PA up. Right, back to full power. I need to have this for peak. It's there, and then drop the power with that one to 4 watts. Hopefully we've got something equal. So 4 watts on channel 1, sorry, 4 watts on channel 40, 4 watts on 1, 3.9 on channel 40. That's about what we expect. None of your 2.7 watts from a new set. So it's 4 watts, 4 watts, 3.9 watts, and let's have a look at what the low power now is. And low power, it's balanced out better. It's 350 milliwatts, and hopefully our current consumptions come down, because it looked like high at 1.7 amp. I expect these to be 1.5, 1.6. I'll just go back to full power. That is 1.24. It's better. Right, we'll do the deviation. So I'm going to plug into the test set behind. So we'll look at the frequency now. Just now slightly a bit higher than I would like, as things have warmed up over the last few hours. Right, what else? Just check the deviation on this one. Wow, it reads correct on that one. I don't know why I got 5 on. It was 2 plus 1.5, it's now 2 plus 2. 27,79131. I'm going to have to take the front off because the meter's not enjoyed its trip back from Stockport, and the meter scale's brushing up against the meter itself. I'll just sort that out. Right, so we've got that back together. I've gone over the board with isopropyl alcohol so it's nice and clean. And the meter thing hasn't is back in where it should be. So that's transmit done. Let's just go do the receive. I'll tell you what, we could do the meter. Transmit meter is adjustment there, so it's supposed to be in the centre of the red zone when you key up. It was just slightly high a bit. Wallow. Right, receive. We'll start by doing the detector. So put the oscilloscope on, switch to camera 3. 100 microvolts on the signal generator. Checking we're still on frequency. We are. Detector is here. I've no reason to believe it's at all wrong. It is, that's what transit does. So do the front end next. Go over to the SINAD meter. Spot on. Spot on. Spot on. You can check those two between the meter on the front as well as the other two. A bit I've got to knock out frequency. I'm good at that. Okay, back to where we were, putting a bigger signal on. Just can't see this. And just do those two. Spot on. Spot on. Really, it's just the detector slipped in transit. So, are we getting a worse reading now? Oh no, we're not. 0.21 for 12 dB. .2. Now, it was that one which made me think, because I think the detector was slightly out. Yeah, 0.42. There you are. So these things happen in transit. That's now correct. Switches, that only one there works. I need to clean that extension speaker socket. We need to just check where squelch is now. Right, squelch to full. So I'll show you the attenuator. But at 1 microvolt I want it to come into 100, which it did before. It's coming at 30 now, so I'll have to just adjust. Tell you what, do the meter first. Right. Squelch. Now take this to 100. It opens. That's where we want it. As it's just because the detector had gone out, it was giving us that false. Set threshold. Signal generator back on. Power to 0.3 of a microvolt. Straight in. So we've got exactly the same figures as we had before, but I've had to alter it to get that. So we've done that. And I'll just clean the volume control. I've just felt a little bit of something. Good. I reckon we're done. Well, that is nice. So, making the, where did I put the lids? Oh, I'm forgetting, aren't I? Is that socket? Because they've got contacts inside them. I'll just go to our normal extension speaker. And then we'll plug the internal speaker in. So we'll try and get an on the air test done right away, so I'm not going to put all the screws in. But I'll just put the one in. So I'm going to unplug the speaker, internal, external, internal, external, internal, external. Good. Right, we'll go to the roof aerial, turn the test equipment off, put the squelch on. Give it a clean up later. One and a Roger. Nineteen a Roger. Notice it lights up red, the meter, when you press transmit. Just like the Mustang. It's the same chassis, isn't it? Good, that's very satisfactory. We'll do it on the air test. Thank you for watching Harvard 402 MPA from 1981 using the Cybernet 002F chassis.